All right, students, welcome to week 7. This week we're going to do module 4. We're going to cover functions, tuples, and dictionaries. Same stuff as every other week. You got a video, you got the Net Academy lesson, and this week we're just submitting some screenshots and doing the test for module 4. So we're going to complete module 4 this week. We'll jump into PyCharm. And the first thing we're going to cover is functions. A function is something that you need to use when you find yourself repeating code often in a program. So when you start writing longer programs, bigger programs that do more things, you'll find that if you want to do the same thing, whether it be a calculation or printing something, or if you're doing the same thing repeatedly and you find yourself repeatedly typing the same code, that code should probably be contained in a function. So you just call the function and pass it the data that it needs to perform that function. It took me, I wrote several programs before I started using functions probably the way I should have. When you're writing linear small programs, and they're just kind of you know step 1, 2, and 3 in order on a little bit of data, you don't tend to see the need for a function. You won't see the need for it. But as your programs get bigger, more complicated, and you do start repeating yourself, you're going to want to use those functions to cut down on how much code you're typing. It may be a little difficult based on this week's lesson to understand why you would need a function, but I promise if you continue on, you'll find yourself using them more often. So to keep it simple, defining a function. So you're familiar with the print function. You're familiar with the int function. You're familiar with the string function. These are functions that you've already seen. They're built into Python, and there's code behind them. You just can't see it. If there is no built-in function, you have to create it yourself. You know, if there's a calculation, a formula or something, you may want to put it in a function. But to keep it simple, we're just going to call, I hate to use that, that's the keyword, you can't use that. So simple function. And this function is just going to print hello world. Super simple. This is a function and it's been defined. Don't forget your little semicolon here. Now, you defined a function, but if you run it right now, it's not going to do anything. You have to call the function. So simple function. So you define it, you tell it what it's supposed to do, and then you have to call it for it to be used. So if you run this, oops, I hit debug. I don't know why I do that. We're just going to run it, and you see it prints hello world because we called the function, and this is printing hello world. This is the only line of code that's doing anything in the program right now. So if your definition could be, 100 lines of code to call it and get it to fire off, it's just one line. It's really simple. That is probably the simplest function I can come up with right now. And I hope that helps you when you're doing this week's stuff. Now we need to talk about scope. If you define a variable inside a function, it is only visible inside that function. If you define a variable outside that function, it is not visible inside the function unless you pass it in, unless you tell it it's there. So here I've got two print functions, x and x, same variable. They're actually different variables. They're just called the same thing, but Python sees them as two separate and distinct things. If I run this, the first print is inside the function, right? This is the first one that appears in the code. Inside the function, it's printing x is 5. But outside the function, the x is still 25. It hasn't changed anything. And this is what this is what they mean when they're talking about scope. If you want to perform a calculation on a variable that is outside the function, you have to pass it in and then return return the result inside the function, unless you use a global variable. And I'll show you. Well, let's make this x5. We're going to pass the argument into the function. Now you have to do that in the definition and when you call it. So when you define the function, you have to tell it, hey, you're going to receive a variable. You don't have to be terribly specific. It doesn't know if it's getting a string. It doesn't know if it's getting an integer. It just knows it needs to get something to do something. So x is going to be equal to x times 2. We're going to double the number. And then we're going to print x. And then we're going to print x out here. So if I run this, you can see, so x equals 5. Inside the function, we double that and we print x. So we get 10. Outside the function, it still didn't change it. It still recognizes the x as 5. So it doesn't change outside the function. In order to get it to change outside the function, there's two different things you can do, I think. Let's see what happens. We're going to return return. We're going to return x. And then, so let's run this real quick and you'll see what happens. Probably nothing. So you returned x. The only print function we have is still x. X is not changed. In order to see this, we have to assign x the variable name. So x is going to be equal to the result of the defined function, simple function. You probably should, so this is going to get confusing. All these x's, they're really all different variables. I'm just giving them all the same name. So let's say y is going to be the result of the simple function. I'm going to print y, and let's also print x, just to show you. So y, the first print is y. We can see that it's 10 because we returned this result. So y is going to be equal to the result of whatever calculation, whatever it does inside that function. So you can declare a variable and assign it the value of a function. But x hasn't been changed. Now, if you want to let's do scope real quick so you understand what's going on. Oops. I'm going to call that. Nope. Let's call it scope. So maybe this is a little better. In this case, we haven't passed the variable to it. We've just referenced the global variable x, which is defined out here. So before we did a calculation in here, we'd have to return a variable or print it inside and it would be different. But now we get the same result. So inside the function, x has been turned into hello world instead of 5. And it also changed it outside because we referenced the global variable. We're changing that global variable. I hope that all makes sense. The easiest thing to do, or the most common way you're going to use these is by passing the variable in, performing some function. Ooh, plus 5. Let's do 5. Put a plus. And then returning the result. And then It's probably the most common way you're going to use it right here. Now, returning y, don't get caught up in x equals x equals x because they are different variables. They may all be called the same thing. And this, again, this is going to come with experience when you start realizing, making your own programs, trying to figure out why something's not working. Just because you call, the Python doesn't even know what that x is. It's just a placeholder for whatever value. The x is for you to understand what's going on. Python doesn't care. So if you run this, you see the x is now equal to 10 because we passed the x in, we turned it to y. So it's going to be x, which is 5, plus 5, and we're returning that value. We could make these all x's if you wanted to, but try not to be so confusing. So we declared x equals 5 up here, and then we redeclared it down here. The x is going to be equal to the result of the scope function, which is this calculation. And we'll return that variable. So it's going to change the global variable again without using global. And then you print it and you get 10. I hope that isn't too confusing. You can do a lot of that with user input as well. So here's a little function that just doubles the number. You have the user enter a number, it performs a little calculation, prints, and it does everything within the function, so you don't have to worry about scope too much. If I run this, enter number 5, if I double the number, it's equal to 10. It works like it's supposed to. But if you're going to do this a lot, you want to put it in a while loop so you can keep asking for numbers and keep going, you're probably going to put this x outside and either pass the global or pass just the variable and do the equals, reassign the value. Maybe global is probably better. So if we just do, we put this outside and then we say global x, and then we run this, enter number, we'll do 10, double it, it doubles to 20, but it doesn't actually change the x, which doesn't matter because it's pretty much gone anyway after you put it in there. So there's a couple of different ways to do the same thing, and that is functions, and we'll do a lot of those later on. They'll get more complicated. Next thing we're going to talk about this week is tuples. Oh, I don't know that I ever use tuples, because a tuple is a list that cannot be changed. It's immutable, and you'll see that term in this this week's lesson. Instead of a list where you would use the square brackets and make 1, 2, 3, 4, 5, this is a list. Let's make this L. This is a tuple. Doesn't look much different except for parentheses, right? You're going to have to remember square brackets are lists and tuples are parentheses. You just can't change a list. So you can do just about anything else to the tuple just like you would a list. Like if you need to iterate for I in L, print I. So it prints 1, 2, 3, 4, 5. You can do the same thing with your tuple. Run it, 1, 2, 3, 4, 5. Same thing. And maybe I should change this so you can see the difference. So you get different output there. You can do, what else can you do? Can you append? see what happens when I do this. So I can add 15 to the end of L. Can I do T? Can I do the tuple? Print the T. See if I get an error. No, you can't append to a tuple. You can't push, you can't pop. You can't do any of that stuff that you can normally do with a list that changes that list. Now you can run calculations on the things that are in the list, but you can't add or change anything in a tuple. And that's tuples. One thing I did want to cover, I noticed, I don't know if it's in a lab or not, but the way you print, there are different things that you can do. So, and these work with tuples or lists. So let's say we wanted to print just a few of the indexes of either the list or the tuple, right? So we got L and T. We're going to print the first element of both those lists. Should be 1 and 6. So you got 1 and 6. You can also do, and we've covered that by index, right? But we didn't cover like negative numbers. You can do -1. Like -1 is going to be the last. Shoot. It's going to be the last index of that list. So if I print this, you get 1, 6, 10, and 5, right? And I'm getting these all out of order. But you get the idea. 1, 6, 10, and 5. So -1 is going to be the last item on the list. Now let's just say you wanted to print 2 through 4, right? So that is 1 through 2, 3. 1 through 3. So 1:3. That'll get you 1 through 3, right? Oops, dang it. So you get, well, it gives you 1 and 3. It doesn't give you 4. Yeah. 1, 2, 3 should give me up to 4. 0, 2. I guess it stops at 3. It doesn't give you that third one. Or 3. At any rate, so this will give you 1 and 2. But if you just do 1 through and leave it blank, you should get the second one all the way to the end. Yeah, so 2, 3, 4, 5, 7, 8, 9, 10. Let's say you just want the 4 and the 9. That would be -2. Or you could do 0, 1, 2, 3, right? -2 and 3 in this case are going to be the same. So 4 and 9. I really just wanted to make sure that you understood the colons. So if I want the beginning, you can just leave it blank, and then I want to the third index. Print L. And square brackets around that thing. So print L from the very beginning to the third index. Do the same thing for T. And I didn't cover this last time. So you can see the square brackets for the list down here in the console, and the parentheses for the tuple. You get 1, 2, and 3 up to the third 0, 1, and 2. You don't get the third one, you get the second one, which is actually the third one. Holy confusion. Remember, they start counting at 0. So 0, 1, 2. You don't get 3, which would be the fourth place. It's confusing, and it takes some time to get your mind wrapped around, but I just wanted to make sure that you were aware that you could do this and access different indexes, because I didn't cover that when we went over lists. So there's tuples. Pretty simple. It's a list that you cannot change. And that is the end of that. A dictionary. Dictionaries, you'll find yourself using, well, it depends on what kind of data you're using, but a dictionary is, again, defined kind of like a list. No, it doesn't. It's got the little squirrely brackets, curly brackets, I guess they're called. Squirrely, curly squirrely brackets. So, and these are, a dictionary is a key value pair. I don't know how best to say, you look up the definition of a word in a dictionary and then you get the definition. So the key is going to be the word separated by a colon, and the definition is going to be the value. So you have a key and a value pair. So these two things belong, like if you're looking at it like a list, this would be one item. Word and definition would be one item, and then it's separated by a comma. And you got word 2, or whatever it may be, because it can be anything. And you got the definition 2, and this would be the second item in the list. But you don't necessarily, you don't access these in the same way. You're going to, like, let's say you want to print the definition of word 2. So you're going to dictionary, and you tell it that you want the value of word 2. So you're going to print the value of word 2, and it should just print def2. So you're accessing this value with this key. You can iterate through these with a for, let's say, key in dictionary, print key, let's just see. Let's see what happens when we just print key. Word and word 2. So those are the two keys, right? I don't know if they can do value now, because I understand value. No, that doesn't work. I forget how to do this for the value in dictionary. Print value. No, it's still printing the keys, but you can access the value. Here, let's do this. Let's say you have, you want to do stuff, and your subject, we're going to do a BMI, a little calculation. How about that? We'll create a key, and the first key is going to be name, and subject 1, he has a height of 74 inches and a weight of 240. And then let's create another one. Let's just do the same thing, but he's going to be a little shorter, a little skinnier. Now we want to create a definition that calculates the BMI, and it's going to accept the dictionary. BMI is going to be equal to, and so here's math. It may be confusing. This is in a math class. Weight divided by, in order for this to work, all your dictionaries have to have the same keys. And buy this again. And then multiplied by 703. So that's, and hold on 1 second. Print the BMI, or no. All right, so the calculation for BMI is the weight divided by the height again. The result of the weight divided by the height again times 703. That'll get you your BMI calculation. This is not a math class again, but don't worry about that. Put this here. So in the first set of parentheses, the weight divided by height, and then that result divided by the height again, and then multiplied by 703, if you ever need to calculate BMI. And then we're going to print the BMI for the name, whichever thing we're looking at here, whichever dictionary we pass it, the name of that key, and we're going to round the result to 2 places. So the first thing I have to do is call this function, and the first one we're going to call it on the dictionary sub1. So you can make this anything. Toby and I don't know, Ron, whatever. You're calling it on the variable. The name is whatever value you've given it to that key. And we're going to run this, and you see the BMI for Toby is 30.81. In order to do that again, we have to call the function again. You see, this may be where functions are useful, because you don't want to have to type this calculation in every time you want to calculate the BMI, every time you get a different subject. If I run this, yeah, so the BMI for Toby and the BMI for Ron. Simple way to use functions, dictionaries, and that looks good to me. I like the way that looks. It feels good. Hope you understand it. And that is a rough over of Module 4. The labs this week are they're a little tough, and they're going to require some math. If you have any questions, shoot me an email. But I'm pretty sure you guys are all smart enough to figure it out. But if not, send me an email. I will probably open the following week, which is your midterm, sooner rather than later. I probably won't wait until next Monday to open it. That way I give you a little more extra time. We're going to do a tic-tac-toe project, and this is you can play a game with the computer where you're putting in numbers. You're going to use lists. You're going to use lists with a lot of empty space in them to get this format correctly. But this is going to encompass everything that we've done so far: functions, lists. I'm not sure if there's a dictionary. You can use a dictionary. There's multiple ways to do this, and as long as it works and your output looks just like mine on the screen, you'll be fine. I'll probably do another video just on this and open it early. Again, if you have any questions, shoot me an email. Thanks for watching.